Welcome to the Explainer. Today, we're going to dive into how you can take control of any application on a Linux system. Pretty much like a hacker. Whether it's running fine or totally frozen, you're about to become the boss.
Okay, let's start with a picture we've all seen, right? An app just stops. It's completely unresponsive, the window is grayed out, your clicks do nothing, and you're just stuck. So what do you do now? Now, if you're on Windows, your muscle memory probably screams Control-Alt-Delete to bring up the task manager. But on Linux, things are a bit more direct. The command line is your direct link. You don't need a middleman. You become the task manager. And this gives you this direct, precise control that, let's be honest, is way more satisfying. Plus, you can script and automate all this, which is a level of power a simple GUI just can't touch.
Okay, let's get into it. The very first step is surveillance. Before you can do anything to a rogue process, you have to find it. You gotta pinpoint your target in a system that might have hundreds of things running all at once.
A really powerful way to do this in Linux is by combining commands. First up, you type psaux, and whoa, you're going to get a massive list of every single process running on your system, with tons of details. Then we use this little symbol, the pipe. Think of it like a hose that just shoots that whole list over to our next command, which is grep. Grep is basically your search filter. So grep Firefox sifts through everything and only shows you the lines that contain that word. It's awesome when you need to see all the details about a process.
But that's kind of a lot to type out for just a quick search, right? And as you'll find with Linux, there's almost always a sharper tool for the job. Enter pgrep. This command is like a sniper shot. It does all that work in one go, finding a process just by its name.
So when you run pgrep Firefox, you don't get a big wall of text. You just get a number. And this one little number is the most important piece of info you're going to get. It's the key to everything else.
This number is the process ID, or PID for short. Think of it like a unique serial number for every single app, command, or service running on your machine. It's the exact address we're going to use to tell the system which process we want to mess with. So now that we can pinpoint any process by its PID, let's talk about control, because managing processes is way more nuanced than just ending them. We can also control where they run, either right up front or hidden away in the background.
You're probably already super familiar with foreground processes. You type a command, like ping, and boom, it takes over your whole terminal. You can't type anything else until it's done or you stop it. It's front and center, demanding your full attention.
But what if you want your terminal back without actually killing the process? Check this out. You can press Ctrl-Z. This doesn't kill it, it just stops it, pauses it right in its tracks. It's exactly like putting it in a sleeper hold. The process is still there, just taking a nap.
So once your process is stopped with Ctrl-Z, you've got a couple of choices. You can type BG, and that wakes it up and sends it to the background. It keeps running, but now your terminal is free. Then, if you need it back in front of you, just type FG to bring it right back to the foreground.
Okay, but sometimes pausing isn't going to cut it. You've got a process that's gone totally rogue, and it just needs to stop, for good. Now it's time to learn how to terminate a process with the all-powerful kill command.
But here's the cool thing. Kill isn't just a single action. The command actually works by sending different signals to a process. You're not just telling it to stop, you're telling it how you want it to stop.
And this is where you choose your weapon. You always want to start gently. Just typing kill with the PID sends the sigterm signal. That's the polite way. It's asking the program, hey, could you please shut down cleanly? But if a program is totally frozen and it's ignoring you, that's when you escalate. Use kill 9. This sends sig kill, and it's not a request, it's an order that the process cannot ignore. The OS just pulls the plug.
And what if you have a bunch of the same program going wild? Like, say you have 5 ping commands running. Instead of hunting down every PID, you can use pkill. As you see here, pkill9 sends that force quit signal to every single process named ping all at once. Talk about an efficient cleanup.
Okay, so far we've been hunting for specific processes that we already know are causing trouble. But how do you spot problems before they even start? For that, we need to zoom out and get a kind of God's eye view of the whole system.
For that, you have top and htop. These are your live system dashboards. They show you a real-time, dynamic list of everything that's running, usually sorted by whatever's eating your CPU or memory. Top is the old-school classic. Htop gives you all the same power, but it's more colorful and user-friendly. Honestly, it just looks cooler. This is the perfect place to spot a resource hog and decide what to do about it.
So let's wrap this all up. You now have the tools to find any process with PS and pgrep. You can manage its state with BG and FG. And you can terminate it with extreme prejudice using kill and pkill. This isn't just a list of commands, it's a full toolkit for system control.
Really, the big takeaway here is that you've gone from being a passive user to an active administrator of your own machine. With the ability to see, manage, and terminate absolutely anything, you are in control. So the only question left is,